Hey, mathletes. What we're going to take a peek at here is angles formed by parallel lines. Now, in the last lesson, we looked at parallel lines again. So remember, parallel lines simply just means that the distance between two lines always stays the same. And our symbol for parallel is this little arrow here like that. So that's your symbol for parallel. So we explored in the last video, in the last lesson, some angles that we get when we draw a line that crosses these two, known as the transversal. So what we're going to do in this lesson is we're going to explore a little bit more the exact same idea, but we're just going to learn some more definitions and some new types. So again, I think it's probably pretty useful to make a list of terms for this unit, right? Vocabulary would be helpful to do. So our goal, remember, for the unit is to use our knowledge of angles and parallel lines to do proofs, just like we did in reasoning. So what we already know is the following angles are congruent when we have parallel lines and a transversal. So vertically opposite. So remember, that's when we're looking for our X shape. And we know that those two angles right there are congruent. They're the same. And so are these two. And corresponding. Okay, so remember what corresponding was corresponding was one on the interior and one on the exterior. Okay, that was corresponding. So what we're going to look at here is a couple more types. So right now we're going to look at something known as alternate interior. Okay, so alternate interior. Well, interior means I'm on the inside, and the word alternate means I'm on the opposite sides of the transversal. So if I go and I look at 3 and 6 here, those are alternate interior. Okay, what does it look like? You can maybe tell me about those two things. Well, it pretty much looks like that those two angles are the same. All right, so that's kind of what we're looking for. Now, we'll prove that in just a minute. But when I'm going to look for an alternate interior, what I want you to look for is your Z shape. So do you see there? I draw my Z, and then on the inside of my Z are the 3 and the 6. So that's one way I'm going to think of alternate interior. But my Z doesn't have to be drawn properly. My Z can go backwards like that. And those are alternate interior as well. Okay, so when you're seeing alternate interior, I want you to look for your Z shape, and it's the two angles that are in the little, I always call it the nook of the Z. I'm sure there's a proper term for that, but I'm not a linguist, clearly. Okay, so there's alternate interior, friends. Okay, co-interior, our next one. So I'm just going to use the same diagram here, co-interior. So what that means is they're on the same side of the transversal. So I would say 3 and 5 are co-transversal. And I would say that 4 and 6 are co-interior angles. That's it. They're on, if I make a C, right? If I make kind of that almost more like a bracket, they're on the same side of the transversal. All right, so a couple more definitions for you. And let's go and do some proofs. That's where the unit starts to get tricky. So proofs. Remember, proofs mean we're showing that something is universally true. So it's always true. No matter what, in the universe, wherever I draw this, it will be true. All right, let's try one of these ones. So, prove the following conjecture. When a transversal line intersects a pair of parallel lines, the alternate interior angles are equal. Okay, let's go for this thing. So what do we know here? We want to prove that alternate interior angles are equal. Okay, let's go for it. So what we're going to do, we're going to set this up. And how we set up our proofs in this little unit, friends, is we're going to set up a little box like this every time, statement and reason. So our statement's usually going to have something to do with angles. And then our reason is why. Why did I make that statement? Okay, so what do we want to do? We want to prove that alternate interior equals. So my goal here This is what I want to prove, is I want to prove that angle 3 is equal to angle 6. That's my goal. So how am I going to do it? Well, when in doubt, I'm going to start just kind of writing down things that I know. Okay? So things that I know. Well, I'm going to start off with going back to last lesson. And what I know right off the bat is I know that angle 3, if my pen wants to work here, that angle 3 and angle 7 are equal to each other. How do I know that? Those are corresponding angles. Okay, right? We learned that in the last lesson. Okay, well, how does that possibly help me? Well, what do I know about angle 7 and angle 6? Well, I know that angle 7 is equal to angle 6. Reason, vertically opposite. So I use two facts that I already know. And now I say to myself, okay, well, what do I have? I have angle 3 is equal to angle 7. I have angle 7 is equal to angle 6. So what do I know, friends? Well, therefore, I know angle 3 is equal to angle 6. And the reason I'm going to give here is substitution. So friends, we now know a new fact, that alternate interior angles are equal. So let's go back and let's write that beside our picture here. So when we've got this Z shape here, friends, what we now know is these angles are congruent, are the same. Beautiful. Okay, let's go for another one here. So what's our next one we're going to try? Prove the following conjecture. Alternate exterior angles are equal. Okay, so again, what are we going to do? Like when you're first starting a proof, you might not know how to go at it. So you just start figuring out first what you're trying to do. So alternate exterior. Oh, alternate exterior. Well, what the heck is an alternate exterior angle, right? Well, an alternate exterior angle is here and here. Oh, take that back. Alternate means I'm on the other side of the transversal. So I'm here and here. So what I'm trying to prove here is I'm trying to prove that angle 2 is equal to angle 7. That's my end goal. So then when I'm stuck, what I start doing is I just start writing down some facts that I know right off the bat. Well, friends, let's use this fact. What do I know about angle 2 and angle 6? Well, those are corresponding. So I'm going to say that angle 2 is equal to angle 6. Reason, corresponding. Then what do I know? Well, I know that angle 6 and angle 7 are equal to each other. Reason, vertically opposite. And what do I now know? Well, if angle 2 is equal to angle 6 is equal to angle 7. Angle 2 is equal to angle 7. Reason, substitution. There it is. There's another proof. So again, when you're first starting proofs, it's tricky. It's going to take you a little while to get the hang of it. Start by writing down things you know, and eventually, they're not always going to be just 3 steps like I'm showing, but if you just keep writing down steps, friends, eventually you're going to probably end up in the right place where you want to be. All right, let's try one more here. What do we got? Determine the value of the missing angle. So the first thing I want to note is I see 2 different sets of parallel lines and I see 2 different transversals. So when I'm trying to find missing angles, I'm looking for my shapes. X, Z, and remember my Z can go the other way. Things like that when I have parallel lines. Okay, so we want to find all these different angles. I know the only angle they're giving us is 115. Well, what I know here is what we just proved, is that A is 115 because it's an alternate exterior. So A is equal to 115. And if I wanted to give a reason, I would say alternate exterior. Okay, what do I know about angle B? Well, right off the bat, friends, I know angle B. I know angle B is 65. Well, how did he know that? Well, look at what we have. We've got a straight line right here. These two angles are supplementary. They add to 180. So I know angle B is equal to 180 minus angle A, which is 65. So that's good. Okay, so now we're getting there. So I'm just kind of chipping away at these things. All right, now from here, well, we've got to go and find angle C. Well, it's hard to picture, but sometimes you almost want to picture like picking this thing up and rotating it. But what you've got here is this angle and this angle are corresponding, right? One's on the exterior, one's on the interior. So what I know about angle C, I know that angle C is also 65. And again, if I had to give a reason, it's because it's corresponding with angle B. There it is. Okay, and now we've got to get angle D. All right, let's go hot pink. What am I going to say about angle D? Well, here's my Z shape, friends. And so angle D is also going to be 65. And the reason for that is its alternate interior. Okay, so it's a little tricky. Like I know the first time I did these, friends, like I'm looking like it's easy because I've done this before, but I get stuck on these too. It's just because I've done a lot of them. So it's just practice, right? You're really looking for these shapes, right? And then you're looking for, am I on the same side of the transversal? Is one on the exterior, is one on the interior? That's corresponding. Are they across from each other? Are they vertically opposite? Are they alternate interior? Are they alternate exterior? There's all these things. So this is where I'd make that list of vocabulary words if I was you, and just draw the pictures beside them and try to help yourself out. Okay. The one thing I also want to note here about the co-interior. So co-interior, which I drew above, but I maybe failed to note it, is that this angle here and this angle here add to 180. They're supplementary. So as soon as I know that this guy here is 65, then I can tell right off the bat that this guy here is going to be 115 because they add to 180. Okay, friends, we're starting to get into proofs of these things. It's getting a little trickier. Do lots of practice.